Hello everyone. Today we are going to be solving a pretty complicated math problem, and I'm going to attempt to lecture you guys on how to solve it. So here's a problem. So it actually looks really tough, but to be honest with you, it really isn't. All you need to do is a lot of work. So what I am seeing in this problem right now is 5 separate math problems. And I'm going to show you exactly each math problem and how to do that. This is a calculus problem. Calc 1 students shouldn't have quite a hard time doing this. It's just, again, a lot of work. So here, without further ado, let's start this problem. So the first off, we're going to simplify this thing. So we're going to take all this. This is now u. So we have the square root of u, or u to the 1/2 to the 1/2. If we know anything about fractional exponents and exponent to an exponent, we should know that we can multiply these 1/2. So now that's just 1/2 times 1/2, which is 1/4. So that should be u to the 1/4, and you can rewrite that as the 4th root of u. So now we're going to plug everything back in for u. So we have the 4th root, we still have a mess, and I'm going to show you what we can do to make this a little more simpler. This is part A. This is going to be our part A. This is our part B, and this is our part C. So we split this up into 3 parts, but there's still 2 more parts that you don't know about. So after you're done solving these 3 parts, you're going to solve this 4th part called the sigma. And then after you're done with that sigma, you're going to solve the 5th part, which is finding the 4th root of the answer. And again, it shouldn't be that bad. You just need to take it step by step. So here is the next thing we need to do. First off, we're going to solve part A. So by solving part A, we need to evaluate this integral. This is, again, basic Calc 1. Fundamental theorem of calculus, we should know this. So we need to first take our antiderivative of 1 over x. That is going to be ln absolute value of x. Here's the cool part. We have our boundaries. E and 1 are both greater than 0. So since it's greater than 0, we don't need this. We can just say this is ln x now. This is ln x. So now we can plug in our boundaries. Ln of e minus ln of 1. Ln of e is going to equal 1, and then ln of 1 is 0. 1 minus 0 is 1. So this is basic logarithmic stuff you should know. Because since you know that natural log is the same thing as writing log base e to the e, which is the same thing as e to the what equals e. E to the 1 equals e. So that's the answer. And then for ln 1, e to the what equals 1. Anything to the 0 power is 1, so the answer must be 0. That's the basics of logarithms. That should be taught in pre-calculus. You guys should know that. So now that we have A, we can plug in this 1 into A. So now we're going to find part B. We're going to find what is this? So by doing that, we need to evaluate another definite integral. Again, this is something you should have learned in Math 75 or Calc 1. So now we need to take the antiderivative of this. The antiderivative of sine of x is negative cosine x. And then you plug in your boundaries. So there's a lot of signs going on right now. So first thing we're going to do, cosine of x. What is cosine of x? I mean cosine of pi. Cosine of pi. That is going to equal negative 1. Negative 1. So now what you're going to have is a negative 1. And then here, we're going to evaluate this. Cosine of negative pi over 3. Okay, so that's going to be 1/2, positive 1/2. Now you're going to add along this negative, and you're going to add along that negative. That should turn into a positive right here. That should turn into a positive right there. So now all we need to do is add these. 1 plus 1/2. You can rewrite 1 as 2/2 plus 1/2. That's going to be 3/2. We can convert that to a decimal, 1.5. And we need to convert that to a decimal because I'm going to teach you right now, C is not going to be pretty. It's going to be a really bad decimal that you need to round. You need to round to the nearest 100th. It's going to be a really bad decimal. So we need to get that going. So once you have B equals 1.5, you can plug that into your part B. So now we need to evaluate part C. You really need to pay attention because there's a lot going on. This is Calc 1 stuff still, but this is a really complicated function right here. So first thing first, let's just, all right, right here. So first, we need to write this as a function. Y equals 4 to the cosine of x over 5x plus the square root of e to the x. Now we're going to do something called Allen properties. We're going to take the natural log on both sides, as shown above. So once you do that, you need to know your Allen properties. So you have Allen of y. So Ln of c to the x is the same thing as x times ln c. So we can actually bring this down here. So we have cosine of x, ln 4, minus ln of 5x. You can rewrite that as ln 5 plus ln x, but I wouldn't recommend that because it's not necessary. So now we're just going to leave that ln 5x. Plus, again, we can bring this, we can first convert this to a fractional exponent. So we're going to have e to the x to the 1/2. Using our Allen property, we can bring that down into our regular thing. And now here's another thing that's important. Ln of e to the x, here's why it is x. So the same thing with the property, you can bring that x down. X times ln e. And if we talked about earlier in a other slide, which slide was it? We talked about it in this slide. Log base e to the e is equal to 1. So if we go back to our slide here, ln of e is 1. So you just have x times 1, which is equal to x. That's why this is equal to that. So now that we plug everything in, all we did here was just simplify that out. Now we're going to derive it. We're going to take the derivative. This is something that's been taught in the early calc ages of Math 75A. So you should know how to derive. So the derivative of ln y is 1 over y times dy dx. And that's going to equal, this is how it works. We can actually rewrite this. I'm just going to use 4 for now. 4 cosine of x. So we have 4 cosine of x. So once we derive this, this is actually negative 4 sine x. So what do you think we can do with our ln 4? We can bring it over here, and we can rewrite it as so, as shown right here. So it's going to be negative ln 4 sine x. Now we're going to take first we're going to distribute this negative, get that negative out of here. Now we're going to derive this, ln of 5x. So that's just the derivative of 5x, which is 5, over the regular function 5x. This is going to cancel out, and that's just going to be 1 over x, as shown above, right here. And then the derivative of a constant times x is just a constant. So in this case, it's 1/2. So we're just 1/2. So the next thing we're going to do is we're going to bring y to the other side by multiplying by y. We need to get y out of there and just leave it with dy. So we're just going to multiply by y. And now we have y times this function. And what we learned about y oh, wrong slide. Y is equal to this. So we can just substitute this for Y. So this is now Y. So this is the original function times the derivative of the function. That is your derivative. Now it's time to plug in our limits. So the first thing we're going to plug in is 3 pi over 2. This is where you can use your calculator now. This is where a calculator is very much necessary. I already did my calculations. So if you plug in this to your calculator, so you plug this into your calculator, you should get approximately 0.029. And then you plug in this to your calculator, and you should get about 0.67. And then you plug in this to your calculator, you should get approximately 0.012. And then you plug in this to your calculator. What you should know already, you don't have to mess with this, because sine of pi is equal to 0. And 0 times anything is 0. So this doesn't matter. So all you have to do is plug in this to your calculator, really. And then once you do, you get negative 0.82, approximately. And then once you multiply these out, you get this. You multiply these out, you get this. And now a negative and a negative, distribute that negative in, you get a positive. So now you're just adding these two up, which is approximately 0.03. We're done with the third part. We can now plug that in for part C. Now it's time for part 4, evaluating the sigma. So using sigma property, I'm so glad there's no variables involved, or else we would have had to use a very distinctive formula. So if you know anything about sigmas, all you have to do really is multiply that by that, since there's no variables. So you just multiply these out, you get 0.045. 0.045. And then the last part is getting this fourth root. So what is that? 0.46. That's your final answer. And here's a little more on sigmas. So if you have a sigma of I equals 1 to 5 of 3, you're just adding 3 5 times. It's the same thing. Dot, 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 plus 3. So yeah, well, we can just do that. So it's just 3 plus 3 plus 3 plus 3 plus 3. So that's the same thing as 3 times 5. That's why this works. And then when you do the fourth root, you put that into your calculator, because why deal with it in your head? Because it's just a mess. So this is what you should come up with. That's our final answer. And that will be all for this video. So thank you all for watching. I'm going to be doing a lot more complicated math problems, and I'll be posting those as well. So keep in touch with me. If you guys have any questions, you can always go down in the comments, and I'll see you guys later. Thank you all for watching.